Okay, basically my video, anti-corruption program. So I'm trying to enforce this as a policy. So the thing about this framework I'm building is something I call scoring, or what I call A-star scoring, which is the best ones go so far, but I know it will break in some things via Trident topology. Definitions. Trident topology. Diamond dependency mitigation. For example, A is a dependency or state. Dependency, is linked to the old state. So it can be a state, a program, a package, a C package, a Rust package, Trident topology. So A is a library or some kind of program, means that accessible program. Doesn't matter what it is. But it's abstract first one. And you get B is dependent on A. Now B depends on A. A depends on B. And then you get an advocate. This is B1. B1. And you now get B2. The same thing, but kind of a different implementation. Sparse. B2 and do the same thing. And maybe problem doesn't really matter. Do the same thing. But use this thing. So when you try to download B1. B1 and B2 via consensus, you get B12. Well, but this is the same artifacts that you're downloading, so the console gets corrupted. So here's the corrupted model here. So you have to define some kind of we have to resolve B1 or B2. So it's either if B2 is the update, we defer B1 to some kind of consistent model. So Trident topology. So the Trident topology is like having some kind of a nil epsilon resolution for that state, hence the triangle model. So you have some kind of auxiliary construction. So, example, mitigation, dependency mitigation, A-star scoring or die-star scoring. We want to use A-star Hamiltonian graph star scoring. Now, what is scoring, and how is it different? What is scoring? Scoring, algorithm scoring, definition by OBNX Namde, me, guys. So we got the Trident resolution for DAX. So we're trying to prune this kind of thing into something that linear. So we can use the sparse mode. We can do A1 to B1 to B to C, or we can do A1 to B2 to C, because C is your executable program, your own library. Now these are two tridents. Here, the part Hamiltonian, and Hamiltonian means like Hamiltonian means a depth first search. So you search depth first. So you start from the node A1 and A2. A1 starts you go down the depth of layers. So you get A1 layer, you go to B1 or B2 layer, and this is where you solve the problem. Resolve B1 and B2 before anything you do. So you can get C to execute a run, or breadth first search. Basically, that first uses the queue. No, uses a stack. So or edge bound. So basically, the edges can do the nodes, which alphabets are. It can do breadth first, change from your problem. So that'll be your package C. So you can start. You can mix them too, but it's about edge. So basically, you get two types of scoring. You get node-based scoring. Node-based scoring, which is artifact-based scoring. Whether you're trying to solve. And you get what judge in the formal definition of that semantic version, X version, node-based scoring, and artifact resolution via A-star scoring. For semantic versioning extended, which is like the major major split into basically you get version 1. The major it's has 3. So you get like a major 1 1 1. I'll come back to this later, but I'll come back to it later. So basically major dot experimental dot legacy or dot long-term support or stable, depending on the kind of composition of the system. And you got minor dot experimental legacy or stable, and you get a patch. It's a patch. The patch encoding for experimental legacy stable. Why this matters for semantic versioning at all? So can you see my what I'm writing down now? It's kind of very poor written, but I hope you guys can at least try to pause this video to make sense of it. Okay, can you see it? Can you see it, guys? Yep, that's the idea. So, I will still define A star scoring. So that's kind of the original stage of the system. So why does this matter with topology? Consensus. Consensus is yes. This is has a triangle model. Consensus. If I say yes to something, I may mean no to it. But you know, if I'm not sure, I can say yes without being sure. So you get true, false, nil, 1, 0, nil. I can say basically if you give me a trial, if you give me a trial of consensus, I give you permission. Do I ability to do it? Yes. Are you giving the permission? Yes or no? I say I'm not sure, so I take the time. Time is of the essence. So I say I'm not sure. Let me think. Yes or no. That well, basically thinking is or space is bound to resource is a screen. I can say then you give me say the same thing again. You ask me the same question. Did you no? Yes. Or I'm still not sure. No, this is not consent. You're not giving me consent. So you've asked the same question twice, but you know now you've gone past permission stage or confirmation stage one, and you got consent. Are you really sure you want to do it? Do you want to confirm you're doing it? And then the last one is yes, yes, so it's consensus. So you now give me the consensus. So I can say yes the first time and then say no. Then say I'm not sure. Then I can say no the second time and say I'm not sure the second time and say yes. Now, basically, I become more sure. Now I say yes, 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 no, and yes. So this is basically it doesn't really matter. So I guess I say yes, no, and no. Why? So basically, this is a 3 by 3 matrix. So the first time I say yes, I confirm I understand it. Now you know you say then I say no. Then I'm not sure about this stage. Yes, yes, no. Then I say yes once. The first one I say I go 1, 0, nil, or epsilon. Then the other one I say no. I say you get 0, 1, nil. Now I'm pretty sure. I'm sure, and I want to take full action of it. So I say 1, nil, and 1. So 1, nil, 1, 1, 0, 1. So I get 1, 0, nil. But this will be because there's 4 1s in this matrix. My automat also be weighted as a yes, as a true. True via Hamiltonian Euleurian which is edge bound graph. This would be like a dependency of like yes you wanted this because there's more yes than no in when you have the score of it. So example, so if you have like one in the matrix, basically there's more yes on the diagonals because you know let me just show you guys here before I fuck it up. So this is diagnosis 1, 1, 1 because yes, no, nil, no, yes, nil, and yes, no, yes. So I'm sure I'm consented to. I'm consenting to it. So, so the idea of this is like a true matrix, Boolean matrix term that can give you some kind of weight. So in this model, if I use the range, that'll be the range of validity. But you know we have a standard mean. Mean is all the numbers, which is standard average, standard division average. Mean mode mean is a rise or run. So the mean will be all the numbers added together. Verified vision uncertainty principle. So what will be the mean here via the A-star score? Let's compute it now. 1 is true. You get 4 yeses, and then you get 4, 5, 6, 4 yeses, 4 yeses, 1, 2, 3, 4, and then 3 no's, and then 2 nils, 2 nils. But the yes would be the median. The mean will be 4 over 4, 5, 6, 7, 8, 9. 4 over 9. This would be times the consensus. That would be the weight of 0 to 1 times 1 times between the range of 0 to 1. That would be 4 divided by 9 times 1 times 1. That would be 1 over 1. That would be 1 over 1, which would be 9 over 9, because 1 over 1 is 9 over 9. So that would be 4 over 9. That would be 4 times 9 is what? 20. 9 plus 9 is 18. 9 plus 9 is 18. 18 times 2 is what? 18 times 2, 6. 16. 16 carry the 1. 2 times 1 is 3. 2 times 1 is 2. 36. So 36 plus, so basically I do 4 times 9 is 36, and 9 times 9 is 81. So the score of this would be 36 over 81, which is the ratio of some arbitrary score. Oh, so get a calculator here.